horrible shape. Even the friction plate explanation of this around the assemblies. Neutral. Welcome to part 2 of my Toyota Tacoma transmission rebuild video. So in part 1, we covered the teardown process for the A340E and A340F. And we also covered the considerations we need to make when we're swapping output shafts for a 4x4 PreRunner conversion. Now, as you can see here, I've got all the pieces ready to go for the A340E, including our new 4x4 output shaft. I will also be showing some of the clips of the restoration and painting I did of the case, the bell housing and the tail housing here, but primarily this video is going to be focusing on getting this all back together successfully. And with that, I ended up buying a master rebuild kit for this job. So that means I have every single O-ring, gasket, steel plate, and friction disc to completely rebuild this transmission. I wasn't originally planning on buying a full rebuild kit. For one, when I disassembled this, most of the parts are in really good condition and probably don't need to be replaced. However, this kind of felt like one of those experiences where it was like, while I'm in there, I might as well do it right, and I might as well have the outcome be a completely rebuilt transmission if I'm going to do all this work to disassemble it anyways. So that was one of the reasons why I wanted to do it. The second reason was more of a vanity issue of I just wanted to be able to say that I rebuilt this transmission. Again, this is a learning experience for me. I've never done this. So to be able to complete that process and really fully understand the entire step-by-step guide to make sure that I do have a completely rebuilt transmission is important to me in this case. And the last reason is also for the value of this transmission long term. If I do ever decide that I want to sell this, I'll now be able to say that I have a low mileage, fully rebuilt transmission available for purchase. So hopefully it'll also be really helpful for you guys to see that process. Even though it's not super involved to replace friction discs and steel plates, it'll still be another added visual bonus for you all to be able to see the complete end-to-end guide there. With all that said, I've been waiting for a while for this rebuild kit to get here, so I'm super excited to get going on this project and get this back together. So let's now get into the rebuild process. I've got the case of the A340E all prepped and ready for paint, so I just took it down to the bare surface with a die grinder, some abrasives, washed it really thoroughly, used brake cleaner, soap and water, everything dried out nicely, and now I have it masked up, ready for paint. So I'm going to throw on some self-etching primer and then a couple coats of this engine enamel. So this should be good for high temperatures, and I'll just make it look really nice in the end. As I said, with this rebuild kit, I do have every single O-ring, gasket, thrust washer, etc. that I'll need for the rebuild. However, before I decided to buy that full kit, I had gone ahead and ordered some OEM parts. So I will have some duplicative O-rings, a couple of gaskets, that type of thing, and I'll prioritize using the OEM parts, but that's okay. I want to make sure that I had everything that I needed, and I'll have some high quality parts for at least some of the stuff. This kit looks pretty good, so I'll have some leftover spare O-rings and such to get me through. So of course, for reassembly, we are again going to be following the factory service manual. What we're going to be doing in addition is beyond the steps for putting everything back together, the manual also has these sort of overhaul sections. So for each of the major sets of components, they have a separate section that talks about how to check tolerances, how to check for wear, how to remove everything so that you can add new O-rings and everything like that. So because I have the full rebuild kit, I'm going to be showing you each of these sections as well and showing you how to overhaul every one of these components. Now, as a reminder on the disassembly, the only thing that I didn't take out of the case was the first and reverse brake piston. So you can see that part is down there at the bottom. The reason I didn't do that is because you need a special service tool that looked like it was going to be too difficult to try to imitate, and certainly I wouldn't be able to find. So I left that in there as we were able to get the output shaft out without any trouble leaving that in. So these first several steps here talk about reinstalling that piston. We're obviously going to be able to skip that. What we can do though is skip to this step here, which is just testing the function of that piston using some compressed air. So we'll start on getting that tested, and then we'll move right into getting everything back into the case. So to test the function of that piston, we just need to make sure we're putting our compressed air into the third hole from the right here. And again, just to describe what we're doing when we're adding this compressed air in these tests, is you're just simulating hydraulic pressure from the automatic transmission fluid being pushed into that port, which usually is the way that these clutches and these pistons function. So I'll show you how that works now. So first up, we've got to put this needle bearing inside. And again, when we stacked everything on the torque converter, it's going to be the inverse. So on top here, you can see that needle bearing that we have. So we're going to install it facing down like this, the race facing down onto the bottom piston there. So we have this hardtack assembly lube, which again will dissolve in the automatic transmission fluid eventually. And I like to use this on the bearing pieces because it gives it some tack and allows it to stay in place as I'm moving things around. After that, we'll get the leaf spring in, and then we'll get into an overhaul of the rear planetary gear set. Now that we've got our leaf spring in, we are already on to the first major gear assembly set. So we're going to now install the rear planetary gear assembly, which does have an overhaul section. So you can see these are the pieces that we're going to be installing. But if we go to the overhaul section here, we can get a better idea of what we need to do. So this cluster does include the output shaft. We don't have the output shaft installed on the stack right now. It's not necessary. But the first thing we need to do is start disassembling the ring gear, inspect the one-way clutch, and we're just going to do a visual inspection on the gears themselves, as well as a clearance inspection on the planetary pinion gear. So if we inspect the one-way clutch here, we want it to spin freely one direction and then lock the other direction. So that's exactly what we have here. So that's how we know it's working. So now we're going to remove the one-way clutch. There is the one-way clutch, and then there are two races, one on either end. So I just removed this snap ring here with a screwdriver, and then this whole assembly will come out with both of the races. So there's the bottom race, and the top race sits on there just like that. With this particular overhaul, the main thing that we're checking for again is on the planetary pinion gear. So we have to check the thrust clearance for the planetary gear on top. So we're wanting to be between 7.9 thousandths and 23.6 thousandths. So you're going to need a feeler gauge that either has standard or metric. They also give you the metric clearance, and we're going to measure that now to make sure that we're within spec. So hopefully you can see where I'm sliding the feeler gauge here for thrust clearance between this sort of top washer and the gear itself. And I am measuring with my feeler gauges right at about 11 thousandths all the way around, so I'm well within spec for this gear. So the second major overhaul step for the rear planetary assembly is we have two new thrust washers that came with our rebuild kit. So we'll be replacing the two that we took off with these brand new ones. I've also got a bin with some fresh automatic transmission fluid, OEM fluid from Toyota in here. I'm going to be storing this transmission likely long term, so I want to make sure as I'm reassembling everything, I just have a bit of a coat of that ATF on there to make sure it stores well. On the sprag, we need to make sure that this little tab here is facing up. So just to note with the sprag, one-way clutch, it's a little difficult to get back in there. The teeth on it are designed to expand outward. So as you're working it in, you kind of need to press the teeth inwards as you're inserting it into the cylinder for the planetary. So now we're going to put the inner race of the sprag back in and make sure that that one-way clutch still works properly. So we confirm that that one-way clutch does still work as it's intended. It rotates one way freely and locks up the other way. Of course, as you're replacing thrust washers, just make sure you're comparing them. The kit does have, some different looking ones that may be similar, so just make sure you're grabbing the right one so that it fits in there properly. With this bearing, we're just making sure that the flange side of the race is facing up when we put it into this component here. Using a little bit of assembly lube just to hold it together a little bit better. As I'm getting ready to install some of the new steels and friction discs, the manual does say to let the new ones soak in automatic transmission fluid for 15 minutes before you install it. So I'm going to give these a little bath. We'll let them soak for a bit before we go ahead with the install. Something that I'm realizing with this rebuild kit and the steels specifically is I don't think it includes the pressure plates. So with these clutch packs, they usually have one of the steels that's a lot thicker, and it's called a pressure plate. So while the kit does include the thinner, steels that go in between the friction discs, it looks like I'm going to have to reuse the pressure plates, which is no big deal as long as I'm aware of it as I'm reinstalling. Right off the bat, I'm not super impressed with the steels in this kit. As you can see, they have a few little rust spots on them. I guess they've probably been sitting in this pack in storage. It is sealed in plastic, and there was some sort of lube, placed in between them, but clearly it wasn't enough and some moisture got in. So I don't know, I might contact the company just to see if they can offer anything, but not super impressed. So I'll try to get these cleaned up best I can and work on getting them installed. We can now use our output shaft to organize these parts as we go to reinstall in the case. So we have the rear planetary assembly here, which will slide over the top, and that'll seat on the gears on the bottom, just like that. And now we can start putting on our friction discs and our plates. With this pressure plate, we just need to make sure that the angle of the teeth on top are facing down. So you can see that there's a slight chamfer on there. We want that to be facing down. Also, if you want to know what it's like living in Western North Carolina in the fall, we've got a family of 4 feasting over here that couldn't care less about me going over there and banging on a trash can with a wrench. So I've got my head on a swivel here because I don't want these guys to finish up over there and then come visit me. Looks like the cubs are getting big and getting ready to take the long nap for the winter. So when we go to get this rear planetary gear set into the case of the transmission, there is something we need to pay attention to in regards to the teeth on the steel rings. So you can see here, we've got a set of the steel rings in the diagram that are all aligned in one direction. And you can see on this one here, the A and the A. So the teeth need to line up with this specific location in the case. So the way that translates is, you can see how I've got my steels aligned here. So this set of teeth right here needs to be aligned with this. Sorry, it's a little hard to see. With this hole, and I'll get a better shot of me installing it, but you'll see how it slides into the grooves accordingly. As we're getting ready to install this rear planetary gear assembly, the manual does want us to also install the second brake piston assembly at the same time. So we're going to have to go back and do another overhaul section before we're ready to put that in. So we can see with the second brake piston here, the way a lot of the components on this transmission work is you have a drum of sorts, you have a piston with O-rings, and then you have a return spring. So the way that this functions is hydraulic pressure, usually through, there should be a port here somewhere, right there. Hydraulic pressure will raise the piston up and down, so you can simulate that with some compressed air. It raises up and down, and the return spring in there, you can see the springs all around, function to return that piston to its normal place when the pressure is removed from that area. So in order to overhaul this, because we do want to be able to get in there and get these O-rings out, there is a retaining spring or a retaining clip, as you can see, which is not too abnormal for this build. However, there's a large amount of pressure being placed upwards towards that C-clip by this return spring. So what we need to be able to do is compress that return spring so we can get the snap ring off. So unfortunately, there's a lot of special service tools that are used in this instruction to do that. So we are going to have to end up fabricating a few tools to make this work properly. And I'm going to do my best to do that. So the first one here, again, this is the second brake piston. You can see they're using a press. So this is the arm of like a 10 or a 20-ton press, something like that. And then there is this almost U-shaped piece of steel, I'm assuming, that is, going underneath the press and adding pressure to that sleeve that holds the compression spring, compressing it enough to allow you to get that C-clip off and then totally, remove this whole system. So what I did was I went to the store and got some 1/8 flat stock steel. I cut some relief springs. Well, I cut it to size first, and I cut some relief cuts in it, rather, you could see in the corners there. And then I just bent it to a 90. So the idea being it simulates this special service tool here. And the way that it works is It'll go something like this on the tool. The press will press on top of that, which will depress this spring a little bit and give me enough leeway to get that C-clip out. So we're gonna see now on my press if that works or not. And we're gonna have to do this a few more times throughout this process, and the tool is gonna be slightly different each time because the retaining spring is different on each of these. So we'll see how we get into that now. You can see here we have an outer O-ring on this piston as well as an inner O-ring. So we've got the new O-ring kit ready to go. So we'll pull those off of there, get these installed, and then we have one tolerance measurement to make on the compression spring before we put it back together. And I'm just going to compare the new ones to the old ones just to make sure that we're looking like we have the same size rings here, which it looks like we are good to go. And you definitely want to make sure that you coat your new O-rings with automatic transmission fluid before reinstalling. Those fit nicely into those spots, so I'm confident that those are the correct O-rings. We just have one more tolerance spec to check here for the second brake piston, and that is the free length of the compression spring. So just to make sure that we are within spec there, we're looking for 16.05 millimeters. Let's see how close we are. So we are gonna call that good because these vernier calipers are probably not perfectly accurate, but 16.05, I was at 16.1, so that's pretty good for me. So now lastly, we're just going to recheck the function of the piston and just make sure it's going up and returning back down successfully before we go ahead and install it. There's a small brake drum gasket here that I actually didn't take out on my initial teardown because I wasn't sure if I was going to get a replacement part for it or not, but my kit did come with a new one, so I figured now I might as well pop it out. We'll reinstall the new one at a later step, but it comes out pretty easy. I just have a brass drift. I'm just pushing gently on it in that direction, and it just pulls right out. It has a bit of a rubber seal on this end, but it comes out pretty easy. Now we've got our new thrust washer to add. So we'll put a little assembly lube on that. And when we install it onto the rest of this rear planetary assembly with the output shaft, the manual does call out that you need the oiling port to be facing towards the bottom of the transmission, so towards the valve body. And the reason for that is this gasket that we just took out, it actually sits right over this oiling porthole and it seals up to that. And that's how transmission fluid will get from the valve body into this brake piston. The manual actually has you leaving the output shaft in there. And the reason that you need these wooden blocks is because when you have the transmission vertical like this and you insert the entire gear set using the output shaft, which you do need to do, you need to have the output shaft inserted as you're putting the gears in. However, once the gears are in, that output shaft will slide out the bottom if you don't have something protecting it, because there's no snap ring or anything holding that output shaft in place yet. So they have you doing this. I'm actually just going to leave the output shaft out for now because you don't need it in there to do this install. And I know that because that's what I did on the A340F when I reinstalled everything into that. So we do have, I'll show you what it looks like. Everything's set up successfully. You can see hopefully where all of the little tabs are aligned, and it's really not that hard to figure out. Like, even if you can't exactly see what I'm saying at this point, I showed you in the manual how the A tab is supposed to be lined right there. You will be able to see it once you get it in here. The other thing, remember I told you that the oiling port on that brake drum was lining up with this gasket. Hopefully we can see inside there. It's a little tough, but there you go. That is the hole that I was talking about. So we know we got that perfect because it now lines up perfectly with the case itself. So we should be good there, and we'll move on from here. All right, so again, we've got all of our gear sets in, and now we are looking at getting a snap ring in. So we have a tapered snap ring that we have to install. We have a clearance check that we need to do with our feeler gauge, a spacer, and we'll be ready to get that other brake drum gasket in as well. Now we need to check the clearance between the last steel plate that we installed and the second brake drum itself. So the spec should be between 27.6 thou and 48 thou. So I'll show you where that is. That's this area right here, and you'll see where I slide the feeler gauge. And mine is right at about 45 thou. So I'm on the upper end of the spectrum, but I think there is a range depending on the configuration of your plates and your flange size. So I'm good for this one, but just know that for different applications, you might have a different reading. Next, we've got to install this piston sleeve. It just sits right on top of the stack, just like that. No snap rings or anything like that. We'll also now install our new brake drum gasket. We're going to coat it with some ATF first, and then it's ready. So we've already installed the thrust washer. We did that in the prior step. So now we're moving on to assembling this one-way clutch. So this is an assembled unit, meaning there is no overhaul procedure for this. It's basically like a sealed bearing type of thing. You can't take this apart. So if this is bad, you'd have to replace the whole unit. So we need to assemble that next. And you can see there's a little hint here. The walls on one side are shorter than the walls on the other side. So you just have to make sure you have the orientation correct. You can see how the walls are deeper on the bottom there, and they're more short on the top. So that's how we need to install it with that on the top. We're now going to install another set of friction discs and steel plates. So this is the first and reverse brake clutch pack. So I have those taken out of the kit. Luckily, the steels on this side were not rusty at all. So maybe it was just that one section that got exposed to moisture, but just so we know, there's only one way that these plates fit into the case, so it's impossible to screw that up. You'll be able to figure it out by the teeth orientation. We now just have a flat snap ring to install on top of that clutch pack. With that snap ring installed, now we have to do a quick clearance check. So between the top flange or the pressure plate and the snap ring, we should have between 24.4 thou and 78 thou. So I'll measure that now. Hopefully you can see this okay, but I'll slide the feeler gauge in now to that spot. And I have about 66 thou. So I am well within spec there. We're now going to move on to the Planetary sun gear, and if I'm not mistaken, there will be an overhaul section for this, so we'll get into overhauling the gaskets on this assembly. So here is our overhaul section for that sun gear. This does have the one-way clutch. This is a fully assembled one-way clutch installed on this section. So we already installed that into the case. Remember, there's nothing to do in terms of overhaul there, so we're mainly going to be thinking about the sun gear here. So the first few steps, we're going to check the one-way clutch, which I already did, and unfortunately I do have it installed on the transmission already, so just take my word that the one-way clutch worked on that race. But now we're going to get into disassembling the sun gear itself. So here is our sun gear. We have first off a thrust washer to take off. We have a couple of these oil sealing rings, so I'll show you a close-up, but they just should come off. Okay, now we have a snap ring on here holding this shaft to the drum. So there's another round snap ring of sorts on the bottom here. You can see I'm not going to take that off. The overhaul section instructs you to do so, but I'm not going to take it off because I don't have one in my rebuild kit. So not a big deal. It looks to be in fine shape, so I'll just leave that one put for now. So besides replacing those oil seal rings, really the only thing we're looking for in this overhaul section is checking the inside diameter of 2 bushings on the sundial shaft here. So there are 2 bushings on the inside I'll show you, and I have a dial caliper that I'll make sure that we're within spec here, which it says the maximum diameter should be 27.08 millimeters. So looking inside this sun gear shaft, hopefully you can see there's a bit of a brass colored bushing in there. I'm not sure what metal exactly it is. It might be brass, but there's a bushing there, and then on the other side there's another one there. So I'm going to be using this style of caliper to measure the inside diameter there. We are reading 26.9 on this side, which is good, and we are at 26.8 on the other side, which is also good. So for my rebuild bits here, I've just got 1 new thrust washer and then 2 new oil seal rings. going to install this sun gear into the case, and the manual says to turn it clockwise as you're getting it seated into the one-way clutch. Up next, we've got to install the front Planetary gear assembly, and that comes with a bearing and a race. So here we have the Planetary gear assembly as well as that bearing and race. So we'll get this popped in there now, and then we'll actually be ready to reinsert the output shaft. Again, I had taken that out, going against the instructions a little bit, but I'll be able to put that in, put on a snap ring that'll retain that output shaft, and then we'll be good to move the case horizontally to finish the work. I don't think I mentioned this yet, but I did actually end up cutting a hole in my workbench specifically so that I could keep the case vertically stood up, but also be able to easily slide the input and the output shaft in and out. So have that set up, and now I'm ready to get the output shaft inserted and put a snap ring on that slot there. I didn't show this, but the rebuild kit also comes with a new oil sealing ring for the output shaft, so I just popped that on. Okay, sorry, that was a bit more difficult than I had anticipated. I actually did end up needing to get this up onto a wooden block. It was just too hard to try to support the output shaft and seat that C-clip at the same time. So I'm not sure how well you can see in there. Let me try to move this a little bit. But right on the top of the shaft there's a C-clip. So now that shaft can't back out, and that's held into place. And with that C-clip installed, we kind of get our first look at the 4x4 output shaft now being in this A340E case. So everything has gone great so far. You can see everything inside is working as it should. All the tolerances have been good, and everything fits really nicely. So we're almost halfway through at this point. Moving on, we've got one more bearing race to install on that front Planetary gear, and then we're going to move into the second coast brake band. So we'll get that installed, and then we'll get on to an overhaul section of the direct clutch assembly. We're going to get our brake band installed now. So my rebuild kit did not come with a new one of these, but that's okay. My original one was still in really good shape, still has the markings on it. So we're going to pop this in. Our next overhaul section is going to be the forward clutch assembly. So if we look at the manual here, that includes an entire clutch pack, but we also have a piston and one of those return springs that we're going to have to figure out. So it looks like we have some fancy dial measurements we got to do here to measure piston stroke, and then we're going to disassemble and work on figuring out another special service tool to get this piston spring out. All right, so with this overhaul, the first thing it's having us do is check clearance or the stroke distance for the clutch pack. So you can see here it's telling us to put the forward clutch assembly in the overdrive support, and then you can see here it just has a basic dial caliper with a magnetic base affixed to some sort of metal piece. And then we're basically just measuring, that is the pressure plate that the dial indicator is resting on. We're just measuring when we put compressed air into the overdrive support here, how much that clutch pack goes up and down. So I know that looks kind of complicated, and I'll show you the setup that I have here. So again, this is the forward clutch assembly. This is the overdrive support. So that's seated in there, and that creates a seal of sorts. So when you add compressed air into this slot, it causes this clutch pack to go up and down. So you can see the setup I've got, and this is all Harbor Freight stuff. So I know there's some specialty measurement tools that I'm using here, but almost everything here can be easily found at Harbor Freight or on Amazon, similar. So this is a magnetic base. I've just got some steel plates stacked up, and my dial caliper zeroed out. Again, we're not on the snap ring, but we are on the actual flange or the pressure plate on top. And then when we add air into that hole there, it's gonna give us a measurement of how much this clutch pack is moving up and down. So the measurement that we want is between 24 thou and 39 thou of an inch. So we're gonna look out, make sure that we're roughly in this range here up to the 30, and that should be about where we're at. So you can see we're right at about 28, 30 thou-ish when I do that, which is perfect within spec, so we're good there. All right, so to get this clutch pack out, we just have a flat snap ring that I should be able to get pretty easily with a screwdriver. And then we have a flange plate 6 steels, 6 friction discs, and then a cushion plate at the bottom, which is kind of this interesting angled piece of steel. So we'll get this popped out. So we have this cushion plate, and you can see it has a bit of a taper to it. So the taper side goes towards the bottom. So we've got another special service tool here, like I said, again, to remove this piston and the clutch return spring. So in this case, like before, we had this sort of U-shaped piece of steel, but in addition this time, it has a ring of steel around it that the U piece will compress around. So presumably in the actual special service tool, that's one, piece of steel. But what I came up with here was using that same U-shaped piece, and then just have a couple pieces of flat steel just to spread the press load a little more evenly. I don't have it going all the way around the circle, but I think I should be okay. You can see the snap ring there, and that's what we need to get out to release this return spring. So we'll get this on the press and see how it does. Oh yeah, that worked easily. Okay. So now we can just pull that return spring right out. And then putting it back in the overdrive support, we can also apply our compressed air again to get the piston to pop out. The manual also has us check this little check ball here, which is part of the piston. They say to shake it to make sure that it's free. So of course, just got some ATF in there, but you can hear that little ball buzzing around. So we know that that ball is free. And there's that other O-ring. Now we need to replace 3 of the oil seal rings on the shaft of the forward clutch drum. So here we have the parts from the rebuild kit, and you can see on the shaft here, there's 1, 2, 3. So I'm not sure what material these are. It feels like a plastic of sorts, but we'll get these old ones off and pop the new ones on. Now the manual says you're supposed to sort of pinch these together before you put them on, kind of like that, just to give them a little bit of tension as you're putting it around the actual shaft. We've just got to do one more clearance check before we put this assembly back together. So we have a bushing on the inside here, and the manual wants us to make sure that the maximum inside diameter of that is 24.08 millimeters. We're getting 23.9, which means we are good within spec. We've got the assembly back on the overdrive support just as we're reinstalling things. So now I'm going to get this O-ring back on the inside of the drum. So now we're going to install the new clutch pack. So I had the new friction discs already soaking in transmission fluid, so those are ready to go, and I cleaned up the steels. So the first thing we need to insert, remember, is this cushion plate. So you can see it sort of has this convex pattern to it. So it goes with the upper side is a little bit higher than the inner side, so that goes facing up like this. And then we'll have 6 steel plates and 6 friction discs. On the very top, we've got our pressure plate. It does have a ridge, and the ridge goes on top. You can see the bottom is flat. So the ridge will go on top, and then we also have that flat snap ring. Doesn't matter which orientation you put this in. With this snap ring, something that the manual says you do need to make sure of is that the opening for the snap ring does not line up with one of the notches. So you want it to be in one of these central pieces here. With the new clutch pack installed, I'm just measuring the piston stroke one more time. So I'm actually getting a number, you can see here. It's a little bit over spec. So it's closer to 40, 45 thou. And in the manual, it says that if you're over the range of the spec, you're supposed to just get a thicker top flange. So I have a 95 marking on my flange. I think they go up all the way to 98. So I think it's like 90 through 98. And each one of them have slightly different thicknesses to account for extra space. To be honest, I'm not terribly worried about it in this case. I took this apart again and I measured the thickness of both the old and new friction discs and the old and new steel plates, and they're identical. They're exactly the same, even on the, the vernier calipers. So I feel like I'm chalking this up to, I cleaned this out. I cleaned the drum out really thoroughly with brake fluid, and I did add some ATF back in there, but I think it's possible that there's just less fluid in the piston at the moment because it hasn't been cycled through the transmission, and that's causing a little bit of discrepancy. Again, I'm not too concerned with it. I might be best off ordering a new flange, but I don't really want that to hinder my project, and it's such a close measurement to what the spec actually is within a couple thou that I think I'm just going to move forward. We've got another overhaul section to cover, so now we're going to do the direct clutch drum. So we have another clutch pack, another piston and compression spring, which means another special service tool. So again, this one has a similar design where you are actually using some sort of U-shaped device with a circular piece to compress that spring. Unfortunately, this time around, this one that I made is not going to work because it's not quite wide enough to clear that snap ring. So I'm just going to quickly fabricate another one similar to this and then hopefully get this compressed. So now that we've got that drum all apart, we've got a number of things that we've got to check here. So one of them is being the free length of the compression spring right there. It needs to be about 21.32 millimeters. We also need to replace the O-rings on the piston. We have to check the inside diameter of the bushing in the drum itself, and then we'll get everything reinstalled with the new clutch pack. That is close enough for me. We're at 53.8, so that's great. And we also just need to make sure again that the snap ring is not aligned with one of the cutout portions. So you can see there we should be good. So I forgot to check this initially on the direct clutch drum when I had the old pack in there, but really what counts is now that I have the new clutches and steels in there. So for this piston stroke clearance, we're looking for between 16 thou and 28 thou. So I just measured it and it looks like I'm a little bit over again. I'll try it again here. You have to put the compressed air into this second from the right hole here. So I'm right at about 30 thou, which, you know, if 28 thou is the upper end, that's close enough for me. Again, I don't know how critical these pack, the piston stroke clearances are, but I'm close enough. I'm inspecting the materials that I'm using, comparing the thicknesses. So I'm going to say I'm good for this, but you make your own call for your side. So after all that overhaul work, we can finally start assembling some of this stuff. So now we're going to put the forward clutch into the direct clutch here. So I did add the new thrust washer onto the direct clutch, as well as we have the assembled bearing and race on the underside of the forward clutch here. I also aligned the teeth of the friction discs as best as I can because those are going to sit on the teeth of this drum here. So here's where we're at. So we just put on the thrust washer and assembled bearing and race. We just put the forward clutch into the direct clutch like we have there. Now we need to put a bearing and a race on top of that assembly, and then we'll get ready to slide on the front planetary ring gear. So that will be the last step before we get to put this whole assembly into the body of the transmission. Just a note on this planetary ring gear, we have a bearing race here as well that's going to sit right on top of the needle bearing there. So for installing this whole assembly where we have the planetary ring gear, the forward clutch, and the direct clutch, to have the rear of the case be up a little bit higher than the front, just the way that the gravity on this assembly is held together, you kind of need to hold it by the rear shaft and get a little bit of gravity working with you as you're getting it set into the Planetary gear inside. So I'll show you what that looks like. So what I mean is you're installing it like this, but the gravity is pushing everything into this case. So you don't want it to fall out, otherwise it'll fall out of the friction discs and then you got to start over. Fortunately, my camera cut out as I was installing that, but you can see what it looks like in the case. And more importantly, you'll know you have it set correctly when the gap between the sun gear and the direct clutch drum is about that wide. So we do have a check actually with our vernier calipers to make sure that this distance is a specific amount, but I can already tell visually just based on me putting the other one together that we have this seated fully in there. So again, we're going to measure the distance between the sun gear shell and the direct clutch shell. Make sure that gap is between 5.3 and 7.3 millimeters. So we'll see how close we are there. And I'm right at about 5.3, so that is perfect. Moving right along, we're now getting into installing the second coast brake piston. So there is an overhaul procedure for these parts as well, but it should be pretty straightforward. We're just looking at a few O-rings and then an oil seal somewhere in here. So yeah, we should be able to move through this pretty quickly, but I'll show you the video now. So to remove this piston rod, we have to compress this spring, and then there's an E-clip on top that we need to get out as well. So I'm going to rig this up into my vise so I can push down on this while getting a screwdriver into removing that little E-clip, and then this whole assembly should come apart. For the rebuild here, we just have a couple O-rings on the cap here, and then one oil seal ring along the piston sleeve here. Okay, so we're ready to install the second brake coast piston here. The main thing that we need to consider is this tip of the piston here, the piston rod, needs to make contact with this lip on the band. And if it doesn't make contact, this whole system will not actuate properly. So I'm going to try to get a good shot of what I'm talking about when you insert, and I'll get a side view as well, but when you insert the piston into its slot, the tip of it will protrude a bit, and I'm going to try to hook in one of the holes of the brake band itself. So there, you can see right there how the tip of that piston rod is pushing up against that band. That's how the system works. When this piston is actuated, it tightens that band around the assembly. So you need to make sure that the lip of that band is getting caught on that piston rod. I messed that up on the other assembly that I did, and I had to go back and fix that step. So I'll show you what that looks like from the side installation now as well. All right, I've got a little installation tip here. So like we just showed, we have the piston with the rod that's pressing onto the second brake band. There's also the cover. So the cover has two O-rings on it. And when you go to squeeze everything together, everything is held in with a snap ring. The problem is getting this cover past its second O-ring to be fully seated to expose the hole for the ridge for the snap ring is very difficult to do by hand. And I actually couldn't get enough force on it to get that to happen. There's a large spring in there, as we saw, and that spring has a lot of outward tension being placed on it. So this is something I ended up having to do on the first install as well, but actually worked really great. I just have this clamp that's stretched across the entire case, have a piece of wood supporting on this side with the screw handle directly in the middle of the cap. So when I just tighten the screw handle down, it works pretty well to get that cap past the snap ring line enough for you to get in there, and you can just slide it around the back. Make sure that that snap ring is fully seated in there, and then you can release the clamp, and everything is now flush and fitted in there. With this whole assembly now installed, we just have to make one check on the piston rod stroke length to make sure that when pressure is applied to this system, that it's applying the right amount of pressure onto this second brake band. So the manual wants the stroke of this piston rod when compressed air is applied to this hole to be between 1.5 and 3 millimeters. So we're going to check that with a little bit of compressed air. I've just got a 3 millimeter Allen wrench here that I'm going to use as my gauge to check the stroke length. So hopefully you could see that well enough. It might be kind of hard to see the witness marks on there, but I can tell where the edge of the piston is starting and where it's ending, and I am right at about 3 millimeters, so I'm good there. And here's that section written out. It suggests that you place a mark on that piston rod so that you can check the stroke length, but just take my word that when you're seeing it in person, you just from the oil marks on the rod itself, you'll be able to see how far it's actuating in and out for this test. To note that if the rod stroke is outside of this range, if the stroke is more than the specified range, there are 2 separate piston rod lengths that you can choose from. I don't know what Toyota's reasoning is for giving you one or the other, but for mine, I do have the longer of the 2 already, but mine was within spec right at about 3 millimeters, so we are good there. With our next step being to install the Overdrive support subassembly, that means we've got another overhaul section on deck. So in this section, we have to replace a couple of O-rings and a thrust washer, and I believe that's it. It looks like we have also a couple of oil sealing rings, but that should be it. So that said, the first 2 steps here, it's having us check the piston operation of this Overdrive support. To do that, I would have to take out the direct clutch assembly again and get this installed on that and then test it sort of sitting upside down on that with some compressed air. Because I already installed that into the transmission, I'm not going to take that back out to test this. I feel pretty confident that the stroke of this piston is working correctly, and we're also going to replace these components anyway. So I'll get right into removing the return spring and snap ring. This one is a little funky. You can see the special service tool here, sort of this X pattern. So I'm gonna have to see what I can fabricate to make that work on the press. So here is what I came up with. I ended up just welding some of this flat stock together to again simulate the special service tool here, which is this X piece of steel. Theirs is probably thicker than this. I'd say this is about as thin as you'd want to go because you're going to be putting a lot of downward force on there and it'll probably deform a little bit, but you can see we have the Overdrive piston here, and you can see how this would sit in there. So it has these little lips on the return spring that the special service tool would sit on. The press is going to drive down in the center, and it's going to put equal pressure, sort of compressing that spring downwards, and then I'll be able to get in, and it's kind of hard to see, but the snap ring there will release, and then the whole return spring will come out. So I probably didn't have to do this. I'll honestly take any excuse to use my welder, but I would bet that if you wanted to, you could get away with just having one piece of flat stock across, so just compressing on 2 of the sides. I would assume that would, compress everything equally enough where you could just pop the snap ring out, but, I figured why not give it a go at making the simulation of what the actual special service tool would be. So let's get this on the press now and see if it works. We've got one quick check on the standard free length of the compression spring, which should be 17.03 millimeters. And then all we've got to do is replace the O-rings, the oil seal rings, and we'll put this all back together. Now with this piston, you're supposed to again use compressed air in this hole with this installed on the direct clutch drum to pop this piston out. But again, I don't have that out, so I'm gonna see if I can just pull this out with my fingers. Okay, that was easy enough to do with just my hands. So we have one outer O-ring and then one inner O-ring. Okay, so we got the piston all pressed back together. The snap ring is on there. Just a couple of things that we need to make sure we have aligned that the manual calls out here. So The two things that needs to make sure that we're aligned on are the piston, the orientation of the piston in the body, as well as the orientation of the opening for the snap ring. So it's kind of hard to tell in this diagram, but section A here is referring to the orientation of the piston. And you can see section A, there's this little section here. It looks like kind of a semicircular pattern. That's the edge of the piston. And what that's trying to call out is this flange. So there's 4 like tabs on the piston, and it says that that should be in line with the gap on the piston or on the overdrive support body. So that gap is right here, and we have that tab aligned. So that's good. And then section B down here is just referring to the opening for the snap ring. So opposite that opening in the body, we want the opening of the snap ring, which happens to be behind one of the tabs on the piston. So you can see we have, let me get a light here actually. You can see we have the opening for that snap ring exactly where we want it, opposite the opening on the body. So just make sure that you have those in the right orientation before you move on. Now that we finished our overhaul, we're ready to install the overdrive support assembly into the transmission. So we've already accounted for our bearing races as well as our new thrust washer. And then what we have to do next is insert the support assembly. It has you using 2 long bolts of a special service tool to sort of aim the support into the body of the transmission. I know you don't have to do this because I didn't use this special tool on the other one that I assembled, but what it's talking about is there are 2 threaded holes in the body, which you can get some sort of puller tool and just, it'll help you sort of, you know, drop it into the case. But I know that we don't need to do that, so we're going to be okay there. And then we need to go ahead and affix the overdrive support assembly with 2 bolts. So what that means is in the case itself, we have 2 bolt hole locations, and on the body of the overdrive support, you'll have 2 threaded holes, which these 2 12mm bolts feed into. So we will get this in, make sure we're lined up with those 2 bolt holes, and then we'll tighten these up just hand tight for now. We've now got a large tapered snap ring to install. So the flat side goes towards the rear, and then we just have to make sure that the opening is towards the valve body, so towards the bottom. With the snap ring in, we can now torque these 2 12mm bolts to 19 foot-pounds. Now we got to take a quick measurement of the end play of the output shaft. So now that all this stuff is installed, they want us to sort of wiggle the output shaft back and forth and see how much play we're getting there. Should be between about 12 thou and about 40 thou. So we'll take that measurement now. So we are just over 30 thou, which is perfectly within spec. Next, we've got the overdrive brake clutch pack as well as a snap ring. One thing that I will say is in the manual, it says this clutch pack has 5 discs and 5 steel plates. In what I took off of both this transmission and the A340F transmission, I have 4 discs and 4 steel plates. So that's what I'm going to be putting back in. My rebuild kit did come with 5 apiece. I'm not exactly sure what the discrepancies are. I know for different vehicle applications, the clutch packs are assembled differently. So while this is the Toyota Tacoma manual, it's possible that there's just slight variations based on years and things. So I would recommend going with whatever comes out of your specific unit that you put back in. We've had to do all sorts of crazy configurations of this dial caliper in this job to make sure that we're checking the piston stroke accordingly. So we do have another one here. It actually wants us to check the stroke from the source of the actual piston itself down here, but I don't have a dial caliper with sort of an L-shaped arm on it to be able to get to that spot. So I'm just gonna do it from the top of the pressure plate and call that good enough. It might be a little bit off, but anyways, the spec we're looking for is between about 68 thou and 80 thou. All right, so we were almost at 65 thou there, and I'm just gonna call that good. Just made an interesting discovery on the overdrive clutch pack that I pulled out of the transmission. Once again, I have these little bites taken out of the friction discs, and that same thing happened on the A340F that I disassembled, and I thought that it was probably because something was wrong with that transmission. But you know, my transmission was in really good shape, only about 115,000 miles, and wasn't, you know, malfunctioning in any way. So I don't know, I'm just curious, does anyone that knows more about transmissions than me know why these friction discs would be getting these little bites taken out of the teeth? But anyways, the new clutch pack is installed and we're ready to move on. We're now on to the last major gear assembly set before we get to the oil pump, which is the final stages of our assembly here. So for this section, we have a pretty hefty overhaul section to cover. So this pack consists of the Overdrive direct clutch drum, which has a piston clutch. So we're gonna have to do another, you know, return spring compression. We have some O-rings, that sort of thing. We have an Overdrive Planetary gear. So we're gonna have a thrust washer check. We've got a thrust clearance check. We've got a thrust washer, a one-way clutch to check. And then we have the Overdrive Planetary ring gear. So there's not going to be too much involved there, but we'll just do a visual inspection. So we've got a lot to do, and I've got the pieces ready to go here. So we'll get into the measurements that we need to take. First up, we've got our one-way clutch check, and we know the drill by now. We just make sure that the assembly spins one direction and it locks the other. So we're spinning clockwise, locking counterclockwise. Now we've got to take a measurement of the inside diameter of 2 bushings on the Overdrive direct clutch drum. So there's 1 bushing on the top here, and then there's another one on the bottom inside. So the maximum inside diameter we're looking for is 27.11 millimeters. So we're at 27.1 on this side, which we're going to call good, but obviously that's the upper end of the allotment there. And we're at 27.1 on this side as well. So again, we're good, but that's the upper end of the spectrum. I don't know how much tolerance these bushings have to begin with if they're machined really precisely, but we're gonna call that good. Now we've got to remove the clutch pack from the Overdrive direct clutch drum. So there are only 2 friction discs and 2 steels inside this particular clutch pack, but we do need to get those out, which is gonna require another special service tool to compress one of the return springs. So luckily it looks like one that I already made is gonna work. We don't have a lot of clearance above that Planetary central gear there, but it looks like it will work. I can always add a couple spacers on either side to make that fit. So we'll get that snap ring off, get the clutch discs out, and then we'll put this onto the press to remove that compression spring. So of course we saved the best for last, and that was actually the trickiest return spring to get off yet. And I think the reason being is this particular return string is pretty thin metal, this top piece here. And when I was using this tool to compress it, it was sort of deforming in a sort of U shape here. So this whole piece was sort of bowing, which was allowing me to get the retaining spring off in these areas, but it was still tight in these areas. So the manual does call this out, like make sure you don't, you know, deform the top spring. I think I definitely bent it a tiny bit, but I got it pretty straight again in the end, and I did get it out. So I'm not too concerned because again, it looks pretty straight, but just be careful of that. So really what I probably should have done is like the tool that they have in the manual. It's a U-shaped press sleeve like this, but then it has a bottom piece that goes all the way around the circumference, which essentially compresses everything evenly. So probably should have done that, but you know, in the end it worked out. This is the last one that we're gonna have to take off. So on the reassembly, I'll have to be careful, but we got this out and we can continue with the overhaul. Now to get this piston popped out, we've got the Overdrive direct clutch drum installed onto the oil pump, and supposedly we need to add compressed air into this slot in the oil pump to get this to pop out. So we'll give that a shot. We've got a quick measurement to take on the standard free length of this compression spring. Should be about 15.8 millimeters. That is pretty darn close, so we're gonna call that good. We now have to remove our one-way clutch from the Planetary gear, so we gotta pop off a snap ring, remove that assembly. We're gonna check some clearances of a bushing and the thrust space on the Planetary gear, and then we'll get everything back together. We're now supposed to check the thrust clearance on this Planetary gear set. The spec is between 7.9 thou and 23.6 thou. So I am measuring that thrust and I am getting just at 11 thou. So I am perfect within spec there. So the only other thing we're supposed to check is there is a bushing sort of deep inside this Planetary gear set. Hopefully you can see the brass color there. That's supposed to be a maximum inside diameter of 11.27 millimeters. The problem is the calipers that I have, the minimum clearance that they allow or that they're able to measure is 12.7 millimeters. So I don't have a tool to get in there to measure this. So we're just gonna have to trust that it's good to go, which judging by the other bushing clearances on this transmission, I think will be okay. Gotta make sure the tabs on the one-way clutch are facing up. So we've got a slightly different approach this time. I added a second U-shaped piece of steel to hopefully add more even pressure all the way around the spring to avoid some of that deflection that we experienced the first time. So we'll see how that goes. The lesson learned, that worked way better this time around and we got the snap ring back on really easily. So that's what you should do for this style compression spring. Use a double overlapped U piece of steel here. So we're gonna pop in the new clutch pack now. We've got 2 steels, 2 friction discs, and 1 flange and a snap ring to go on top. With the clutch pack in, we've got 1 more piston stroke check to do here. So I've got the dial caliper set up to be directly contacting the piston versus the clutch pack. That's just how the manual shows it. And we're looking for a stroke of between 72 thousandths and 84 thousandths. So see what we get here. We have to put that compressed air into this slot on the oil pump here. All right, so that was just under 70 thou. And again, we're supposed to be at about 72, 73 thou. So I'm gonna call that good. I'm getting a little lazy with the tolerances here, but we're talking about a few thousandths of an inch difference and I think we're gonna be okay. All right, we can finally start installing some of these Overdrive Planetary assembly parts now that we've finished all the overhaul for them. So first up, we have the Overdrive Planetary ring gear. So just to note a couple things on this, there is a bearing race on the back. There's already some ATF in there holding that on, but you could use some of the assembly lube if you need to. And then on the inside, there's another race that has 4 prongs on it as well as a needle bearing. So we're gonna install it just like this. We can now install the Overdrive Planetary gear into the Overdrive direct clutch as well. And you'll know when that is successfully installed when you're down through the 2 layers of flukes on the friction discs, as well as we can test that one-way clutch again. So we're rotating clockwise and then it's locking counterclockwise. Before we put this whole assembly in, we've just got to put 1 more bearing race on there and I'm going to add some assembly lube so that it'll stick into those slots as I put it upside down into the assembly. I can't remember if I've yet mentioned this in this video series, but you can also just use regular petroleum jelly instead of assembly lube. It works the same way, and that's actually what the manual says you should do. The last step we have to do with this Overdrive assembly is they're having us check the depth of installation for that Overdrive direct clutch and Overdrive Planetary gear set that we just installed. There's another special service tool here. It looks like it's basically just some sort of metal bar that spans the distance of the case, and there's probably a hole in the middle that's used to make space for the sort of extension rod of a vernier caliper. So I'll show you exactly what I think is going on here, but the problem is it's having us check for a specific depth, but we have no idea the thickness of that special service tool, which is going to have to be included in the calculation to get that 15.5 to 16.5 millimeters. So there's no real way for us to check this. We're just going to have to go by feel and visual. I'm pretty sure I have it set in there correctly, but I'll show you sort of what I think is going on with this special service tool now. Okay, so what I believe is happening with that special service tool, like I said, there's some sort of metal bar that spans the width of the case. I just have this Superman's fingernail tool that happens to be a, steel bar with a hole in it. So just imagine this is a special tool that's designed to fit the exact width of this case. There's a small hole in it, and then on your calipers, when you extend down, you have this sort of drop down arm to measure depth. So I'm assuming it goes something like this. You place the calipers over, you drop it down, and you take your measurement. So again, we're gonna have no idea what that actual measurement should be for us because we don't have that specific width of the service tool. But again, I checked the flukes. There's 4 flukes of the overdrive clutch that it needs to fall into. I can see down there with the flashlight and everything feels and looks right. We'll also have a pretty good idea when we go to install the oil pump if something's not feeling right. But yeah, you might have to do this one visually and by feel because I don't think anyone's gonna get their hands on the exact special service tool. If someone does, if they know the width of that or the dimensions of that, let me know. But otherwise, we're going to go visually here. For anyone still watching, thanks for making it this far. And we are on to our final major overhaul. So this is the oil pump, and that'll be the last major assembly that we put into this section of the case before we get the valve body on. So we do have a number of things for the oil pump that we've got to check. We have some bushings to check. We have some clearances to check. We've got to overhaul a few oil sealing rings. So we'll get into that and hopefully get this installed quick. So this is the stator shaft assembly. And we've got a couple of bushings to check there. And then this is the main oil pump body, and we have to check a couple of the clearances in here. I'm getting these components cleaned up a little bit, but we do have an oil seal on the main pump body here. So I have a new OEM one. So I'm just gonna use this Lyle seal puller to try to get this old one out before I clean it up. All right, this one doesn't seem to be working too well. I'll switch to my other type. Before we reassemble here, we have 3 bushing measurements to take. So we'll do the first one, which is in the oil pump body, this large bushing up front, which we're looking for a maximum inside diameter of 38.19 millimeters. So that is reading 38.1, so we're good there. Now on to the stator shaft here. This top one should be a maximum inside diameter of 21.58 millimeters. So we have 21.3 there. And then on this side, we're looking for 27.08. We're at 26.9, so we're good on all 3 of these bushings. So we're supposed to check some of the clearances between the drive gears and the body. The first one we're supposed to check is between this drive gear and this edge of the body here. And then the second one is between this crescent shaped piece here and the drive gear. So the clearances for that are incredibly small. For the edge of the drive gear to the edge of the body pump, it's 2 thousandths of an inch to 5 thousandths of an inch. And then for the the drive gear to the crescent shape, it's 0.2 thousandths of an inch to 9 thousandths of an inch. So incredibly small. And I can already guarantee you that none of my feeler gauges are going to be able to even get into those gaps. There's virtually no gap in that space. So I know that I'm good there. I can't take a measurement because I don't even have a feeler gauge that small, but I know that these are within spec. It was the same case when I disassembled the A340F. These were all extremely tight. It also wants us to take a measurement of the gap between a steel straight edge spanning the body here. So you can see I just have this, this right angle measurement tool that's spanning across here. And there's supposed to be a gap between the drive gears and this steel thing that should be between 0.8 thousandths and 20 thousandths. So again, an incredibly small amount. I don't have a feeler gauge that small, and I don't even see any space between that, so I think we're also good there. These now need to be torqued to 7 foot-pounds, which is 84 inch-pounds. These bolts need to be torqued to 16 foot-pounds, which is 192 inch-pounds. Just going to check to make sure that everything rotates smoothly. I'm just twisting the output shaft here, and you can see we have good connection up front through the oil pump into the input shaft. The manual wants us to now reinstall the case plug into this port here. And again, just remember, 2003 and 2004 Tacoma, you're going to have this, and then 2002 and earlier Tacoma, you're going to have the kickdown cable going in through this port here. So I've got this baggie full of small O-rings that came with my rebuild kit, so I'm going to see if I can find one that fits this. I actually forgot that I bought the OEM version of this particular O-ring, so I'm going to install that one onto the case plug, not one from the rebuild kit. There probably is a torque spec for this, but it's definitely got to be under 10 foot-pounds, so I'm just going to snug it up with a wrench. Make sure you're checking your clutch packs too after you've got everything together. So this step just has you doing that, blowing compressed air into all these holes. I just checked all those, they all look good. So next we got a series of steps that we're reconnecting that parking lock rod. So we've got some oil seals and then all the parking lock components themselves. So we'll get those in now. So we're getting ready to put that long rod through those two oil seals that we initially took out. And we have to get this little parking pawl and the spacer added on as well. So remember, this spacer in the teardown, this is the one that we had to use a Dremel to remove. So the idea is this is a non-removable part that you have to, cut off essentially. So the way this works is this will be mounted on that rod. There will be a roll pin that goes through those two holes there, sits tight. This spacer, we'll put this on first and the roll pin will go in through there. Once we get the roll pin in, we'll rotate this spacer to cover the roll pin. And we have to make sure that this little hole in the spacer is lined up with this indentation on the parking pawl. So I marked it with a little paint marker so I know where it is. So the idea is that hole goes over there. You use a punch to sort of set that spacer into that notch. So now that roll pin is locked in there. This spacer can no longer move and the assembly can't come apart on you. And with this rod, make sure you insert it so that the threaded side is on the side with the second coast brake piston. That is what the shifting arm will screw onto. And then this side will have the park neutral sensor. We have our new roll pin here. There is a hole in this parking pawl. There is also a hole in the rod. So you have to make sure those line up and then make sure the spacer is set so that you have this little U-shape cutout aligned. And we are going to drive the roll pin all the way through. And once you drive it into the point where you can rotate the spacer over it, you've got it in far enough. Now to lock that spacer in place and thereby locking the roll pin in place, we have to stake this little indent into the parking pawl and making sure, again, we line it up with that indentation, which we've already marked with our little marker. So that is now staked in there really well, and that spacer is not moving. For the rest of this assembly here, there is a specific order in which we need to place the components so that we essentially get this large pawl to lock correctly onto this Planetary ring gear here. So the first thing we need to do is insert this, and then we have this rod here that will go through and a spring to connect onto that. Now the key with the spring is that this bent arm here has to go underneath this pawl. There's a little slot for the straight arm to sit into, and you'll see when it's all the way down, this pawl will rest on there just like that. Now we need to connect this long rod onto this pawl up here. There's some teeth that slot into a groove here, and then this has to go on top of this large pawl. So we'll bend that down, stick the end out through the hole in the case. Make sure we have that in there. And then we're going to press this forward a little bit. You can see we can rotate that locking rod, and there's a little indentation in the large pawl that is sort of the same conical shape as this piece here. So we just have to make sure that that sits right in there. So that will rest into position there. And then lastly, we just have this cap that holds the whole assembly into place with 3 bolts. So this little arm sits on top of this shaft here, and then we'll connect it with our 3 10mm bolts. These 3 10mm bolts now get torqued to 65 inch-pounds. And if you've ever wondered how your transmission works when you put it in park to lock up the system, you can see we're freely rotating the output shaft here, and we shift this parking lock forward. It locks this pawl onto the teeth of that Planetary ring gear, and the whole system is locked up. So that's how park works on your transmission. We're about ready to install all of our accumulators into the transmission body, but first I've got OEM O-rings to replace on all these, so I'm just gonna pop these off quick. So just so we know the naming of each of these pistons as they go in, this one is the B2, C2, B0, C0. And then lastly, we just need to put this check ball body with the spring into this opening here. And we're nearing the end. We're on to basically the last major part install, which is the valve body. So while my rebuild kit does come with new valve body gaskets, I'm not going to take this apart and rebuild it because I don't have any new solenoids or anything like that. I did actually end up taking the A340F valve body apart, and I'll show a couple of photos from that, mainly just because I wanted to see how it works. So I was able to do that, cleaned it. I took every single part off, every check ball, everything, took it apart, cleaned it, got it all back together successfully. So let me know in the comments if anyone would be interested in seeing a valve body rebuild, or at least a disassembly and reassembly, maybe a disassembly, cleaning, you know, change the gasket sort of thing. If that's valuable, I can make a separate video on that. For the sake of this video, I'm just gonna reinstall the unit as one piece, but I can do that, and it wasn't terribly difficult to figure out. So with that, we're gonna get this into the case now. Something that commonly gets brought up with valve bodies is a concern over where the bolts go in each of the spots, because there are so many of them that connect them to the transmission case, and some of them are different lengths. Usually people will make some sort of cardboard cutout, put all the bolts into the individual locations, but I'm going to show you a trick that you don't have to do that, and it's actually quite simple to figure out which bolt goes in which location. So to prove that, I'm going to take all these bolts out, shake them around in a pan, and then we'll be able to figure out where they go again. Now that we've got these bolts all shaken up, I did just clean them with a little bit of brake cleaner. First thing we're going to do is organize them by length, and there should be 3 different lengths. Okay, so now that we've got those sorted, we have 6 long bolts, 10 medium bolts, and 4 short bolts. So when we look at the valve body now, we'll pretty easily see that there are 3 different levels of the casting of the valve body, and that's gonna figure out where we put our short, medium, and long bolts. So you can see here, like on the edge, how this section here actually drops down from the rest of the valve body. That's gonna be a short bolt. The majority of them are medium bolts. Those are the ones that are sort of on this level in the main area of the body. And then on the left-hand side here, we have our long bolts, and those are actually higher. It might be a little difficult to see on video, but if you're looking at it in person, you can see there's a little step right here where it lowers. So any of the high areas are gonna have the long bolts. So let me just pop these in again really quick, and I'll tell you which ones are which length as we go. Okay, so we've got the valve body just set in here for right now. It's gonna be resisting you a little bit because of these accumulator springs. So I'm gonna get a corner one started on each side just to sort of hold it down. So first here, this is gonna be a long bolt. Next over here, this is gonna be a medium bolt. Okay, so now I'm gonna go ahead and try to, now that I have those corner bolts in, I'm gonna go length by length. So I'll do all the long bolts first so you'll know where to put them. Okay, so we've got all of our 6 long bolts in. We have 1 medium bolt in on this corner just to hold it down. So now we can finish with the rest of the 9 medium bolts. With this last medium bolt, we have a small bracket that holds the transmission wire, which goes in this last spot here. There's a small tab on the bracket that hooks onto the edge of the valve body. So this is the correct orientation for that bracket. And now we've just got 4 small bolts left. I'm going to zip these down with my electric ratchet and then we'll get them torqued. Also remember, if we were installing one with a kickdown cable, we would have to connect that kickdown cable in this area now. In case anyone wants the written out version of those bolt locations too, you can see the manual very clearly calls that out, each of the different lengths locations. The torque spec for these 10mm bolts is 7 foot-pounds or 84 inch-pounds. We're going to install the transmission wire now. I was able to find a new O-ring in my rebuild kit that fit this, so I installed that. And we've got 4 plugs to plug in. Just remember, on an O2 and earlier, you're going to have 3 plugs. We do actually have a torque spec on this 10mm bolt that holds in the transmission wire plug, and that is 48 inch-pounds. I'm going to reinstall the filter now. So this filter was the one that actually I took off of this transmission. I didn't bother buying a new one because this only has like 10,000 miles on it, and I don't know if you can see inside, but it's very clean. There's hardly any wear on it. So I'm just going to reinstall this. 2 bolts here are the same length, but these 2 bolts are different length. So if I just reference the manual, this bolt here is going to be the shorter, or sorry, the longer of the 2. So this one's shorter, this one's a little bit longer. And the torque spec for these is also 7 foot-pounds, which is, I believe, 48 inch-pounds. With that filter on, we are good to get the pan installed. So I had taken some time previously to really thoroughly clean this pan. You can see it's pretty much spotless in there. I've got 3 magnets reinstalled in there, and I am ready to put this on. So one thing I did want to note, the correct gasket that you're supposed to use for the pan is this Toyota 1281 FIPG. This is for the transaxle case. So I'm not going to do that right now because I don't know if I'm going to want to take this apart again before it gets used. I have no idea how long this transmission is going to sit after I'm done rebuilding it, and I may want to take the pan off at a later date and, you know, maybe do something with the valve body, whatever. This stuff is really difficult to get off and it takes a long time to clean everything up. So my rebuild kit gave me this cork gasket, which again is not the right way to do this, but for storage purposes, I'm going to use this cork gasket so I can more easily take the pan on and off. And these are all 10mm bolts. Now, because this isn't the final install of this pan for me, I'm not going to bother torquing these, but if you were going to be torquing these down, it is 65 inch-pounds for all of these bolts. Got all the remaining external parts that are go on the case laid out here. So we have our transmission revolution sensor, we have our speed rotor, which will go on the output shaft, our park neutral switch, our oil cooler line tubes, a breather hose, oil temperature sensor, and our shift rod here. So I'm going to do a speed round. I'm getting these all installed on the case, and I'll mention any notable torque specs as I go along. This torque spec is 12 foot-pounds or 144 inch-pounds. We're going to do our oil cooler tubes next. The torque spec for these is 22 foot-pounds. However, I don't have a wrench that would fit on this to get a proper torque, so I'm just going to do it nice and tight. Should also mention I've got new O-rings on both of the oil cooler tubes. The torque spec for the temperature sensor is 18 foot-pounds, but again, I'm just going to do it nice and tight. For our park neutral position switch, we have a bit of a more complicated assembly instruction here just to make sure that it's in the right position to be calibrated correctly. So the first thing that we need to do is install it onto the shaft lever, which is fine. We'll temporarily install the bolt, and then using that shaft lever that we just put on the other side, we're going to make sure that the transmission is in neutral. So once we do that, there's a line on the sensor that we need to align with the groove, and then we can tighten everything down and do the appropriate torque spec. Just going to add a dab of multi-purpose grease onto the shaft to prevent the sensor from seizing on there. The main bolt for this sensor, when I removed it, had a little bit of thread locker on it. It was sort of like a yellow paste that a lot of the bolts on this transmission had. So when I reinstall it, I'm just going to add a little bit of blue thread locker just to give it a little bit of extra hold. This nut is a 22mm nut, but the torque spec for that nut is 61 inch-pounds. So I've kind of got this hilarious setup because the only 22mm socket I had was 1/2 inch drive, and the only inch-pound torque wrench I have is 1/4 inch drive. This torque spec is so light that I couldn't even feel the click on this torque wrench when I got to 61 inch-pounds, so I gave up on that and I basically just did it hand tight. So we got to shift this into neutral so we can finish installing that park neutral switch. So to shift the transmission into neutral, we're going to pull the shaft all the way back. We'll confirm that it's in park by locking up the output shaft, and then we go 2 notches forward. So we're going to be reverse, 1 notch, and then neutral, 2nd notch. So now we're in neutral. The transmission is now in neutral, so the last thing it says we have to do is align this small groove here. I'll try to zoom in to make sure you can see that, but there's 2 notches on the sensor. Align that with the groove on the shaft right here, and then we can tighten down this bolt to 9 foot-pounds, which is 108 inch-pounds. So by align, they just mean at this point you can still kind of move this around before this bolt is tight. So just make sure that you're in as close alignment as you can with that. We're going to install the transmission revolution sensor rotor onto the output shaft now. So we need to consider with this 4x4 output shaft, there is a small keyway here, a little woodruff key that sits into that slot, and then there's a slot on the rotor itself. We'll slide that on, and there's a snap ring to hold this together. We're now ready to install our tail housing, which is really exciting, but I did want to mention the overhaul steps for this tail housing, and I have some clips of me doing that, but just to note, there is a bearing on the inside as well as this sort of washer of sorts and a snap ring. So I took those apart, cleaned the bearing. I did also replace this seal in the front here. I replaced these rings, which are the alignment rings when you're mating the transfer case to the transmission. I also replaced this breather hose with a brand new breather hose, as well as this little vacuum hookup here. So have a completely rebuilt tail housing, and we'll look to get this installed now. So just like I mentioned with the oil pan, the proper gasket maker you're supposed to use for the tail housing is this 1281 pink form and place gasket from Toyota. That said, just like the pan, I'm putting this into storage and I may want to take this apart. The reason we do have an oil seal here is because oil will come through these ports. So with that, the rebuild kit came with a paper gasket that I'm just going to use for now for storage purposes. If I go to actually use this or sell it or whatever, I will redo this and use the actual paste form and place gasket. So another thing I just want to mention, you can see the shape of this gasket, right? It only covers this section here. On a normal A340F, you will have to seal this entire area here. That's because this section, which on the A340E casing is closed off, is open on the A340F. So oil will come in through this part on the A340F. On the A340E, this is why only this area is sealed, because there's only oil openings in this section here. So just keep that in mind. I'm gonna just, again, be doing this for storage, so this will be fine for now. Now for our bolts, 4 of them are 50 millimeters and 3 of them are 40 millimeters. So the shorter ones go in the 3 places along the bottom. And again, our 3 bolts on the bottom here are the 40 millimeters. So you can probably see 2 of the holes, and then there's also one in the middle underneath here, and that's the one that we had tapped on the previous teardown video. The torque spec for all 7 of these bolts is 25 foot-pounds. Now we've got the transmission revolution sensor to put in. Got a new O-ring on that as well. The torque spec on this is 48 inch-pounds, which is incredibly light, so I'm just gonna get it hand tight with a ratchet. We're ready now to install the bell housing, which is very exciting because this is essentially the last piece to put this back together. So it's been quite the journey, but I'm excited to see it all together, and I'll get some good shots of it in the daylight tomorrow. So the 4 14 millimeters on the bell housing get torqued to 25 foot-pounds, and the 2 17 millimeters on the bottom get torqued to 42 foot-pounds. And last but not least, the final part on this rebuild is to reinstall this little breather tube. So we have this to get in, and then we just have a 10 millimeter bolt, and that is it. We are done.